Okay, hello everybody. This is our first session of R programming or R coding on the first day of our course on assessment. So let's get into it. So let's start with the first step. What is R? So R programming is a free software environment for statistical computing and graphics. It was created by a New Zealand statistician, Ross Ihaka, and a Canadian, Robert Gentleman. You can notice that the first letters of their names start with R. So unlike other statistical software like IBM SPSS, it is freely available. So this gives you lots of advantages. And you can pretty much do anything you like inside this software program. So educational professionals looking to understand assessment and other school-related data can benefit much from improving their skills in R. So this here is RStudio, and you need to have both R and RStudio both installed on your computer, and I gave a video of how to do that on Moodle. So you should already have that set up. Once you have that set up, you need to open RStudio and then open this file, which is an R file, day one rcoding.r. So the first tip, R tip 1, double click on the top grey panels of each of the 4 studio windows. There's one window here, another window here, another window here, and another one here. So we can resize and double click on the grey areas. Let's see what happens if I double click here. Double click here, it goes up. I can also move the size, change the size. I can change the size of the centerpiece. I can double click on this. I can also change the size here. Another tip is you can use, on a Mac, it's a Command minus to make the print smaller, and Command plus to make it bigger. You can find out what that is on a Windows machine as well. So number 2, setting up working directory. So often the data we work with will be in CSV, XLSX or SPSS SAV form, other forms as well. So if we want to work with data, manipulate and analyze data through this software program here, the RStudio program here, we need to put it in a folder. So that folder needs to be on your computer. And we need to make a link between this session, this instance of coding, with that folder. So to make a link, we call this setting our working directory. So this is done via code. So in a Mac or on a PC, you need to set up on your desktop a file. You can call it EDSE634R. So you need to set that up, and you can see that I've done that here on my desktop. Okay. Or on your PCs or on your Windows machine is also fine. You need to right click on that file and get info. So for me, if I right click on that file and say get info, that's going to give me this file here. If it's a Windows, you can right click and then select properties. But on my Mac, I select get info. Now for my Mac, under general, where, I need to highlight and copy the address. So for me, general, where, I highlight and copy the address, copy. On a Windows machine, you can just check the location. You can check the location and highlight and copy that location. Then you can paste your address just to see it, right? Okay. So after that, you know where that file is, but you need to write the full address for that folder. So all you need to do, for me, I just copy this and put it into here, and then I put a new / and then the name of the folder that I created. And if I highlight this line on my Mac, then and I press run, if I go up here and press run, I run the code, you can see on my Mac it says the other option is Command Enter, which is the little where it says run the, it says run the current line or selection bracket, Command Enter bracket. So that's the other option that I can use. I can press run like that, or I can press on my Mac Command Enter. I'm going to highlight it now and go Command Enter. And it's successful because it's blue. If this were red, it would be not successful. On your Windows, you need to set up your address similar to this here, but you'll have different user and different address here, obviously, for your machine. And when you need to run it, you need to take out that hash, and you need to highlight and run, or use the shortcut key on your PC. But highlight and run on your PC. But I'm going to hash that out because I don't use a PC. So just one moment, there's a little bit of noise in my apartment. So we need to check the color of the output, that it's blue, and that seems blue. We can also double check as well that we've made the correct connection between this program and our file that we're going to get some data from. So we can say get working directory. Highlight that, click enter, or command enter, or run, and yet you'll get the success. You'll get the output. The output of the working directory is, or the address is, here, it's printed for you, so it's correct, so we've made it correct. Now, excuse me, when you're working with data, we draw upon the data from our file or something inside this programming language, and we create data objects. The data objects exist in this global environment here. This is really important, this global environment, because that's where all the data is stored. All the variables are stored, all the lists are stored, all the factors, all the information that we're doing our analysis on is stored up here. So when we start, we need to clear this area. Now we can clear it by running code like this, that code there. If we command enter, we can clear it. We can clear it by using the little broom, press yes. We can also clear the plots that we make here by clicking it here. We can also clear this environment down here, this console, this output console, by clicking there like that. So we need to make sure we're starting with a clean environment when we start our RStudio session. And our RStudio session will just be one project. So I think I may have missed a step. Correct. So task 1, before you get started, is to do some short research about R programming in your own country or region and write a few sentences about that. You can do that now. Task 2 is to write down the address of your working directory. You should have that, it should work, but that's task 2. And you can just do that yourselves. Just a little bit of an extra note, just to make it clear about the global environment. Say, for example, I'd like to create a variable, and the variable is your ages. Now let's see, your ages are this. 19. There's one genius who's 14, okay? Let's assume that there are 1, 2, 3, 4, 6 people in the class, and this is pulled together with C, which means concatenate or join in series these numbers. And we call this an object. We assign these numbers in series to an object. What should we call the object? We can call it whatever we like. We can call it age of students. Yep. So we highlight, and we're replacing this vector, this series of numbers, we're assigning it to this object here. So I can press run. Oh, look what happens. So now we've got this object up here. It's a number with 1 to 6 values, and those values are 23, 24, 25, 21, 19, 14. So this is now an object inside this global environment. What happens if I print the global environment? I'm making a command on that object in the global environment. Print age of student. What's going to happen? Where's the output going to go? Let's wait, let's see. There we go, we're printing it, so there it is there. Age of student means that vector. That's what that is. You can do it another way. You can highlight just the object itself and press Command Enter or Run. Yep, same thing, same output. So now maybe I want to clear. I'll just put another object in there. Age of teacher. What's my age? 42, too old. Here we go. So we've got too many things in our global environment. We don't want to, we're starting a new project. We want to get rid of this other work. So you can do it here. We clear it. It's cleared now. Yeah. We want to clear down here too. We clear it. No problem. All done. So for task 2, you just need to write down the address of your working directory. Task 3, elements in R. So an element is a single piece of information. In R, we can create different types of elements. So a numeric element is just a number. We can assign a value of 5 to object A. Check global environment for the existence of this object. So highlight, Command Enter or Run. And there we go, we've created a numeric element in the global environment. Print A, cool, we can look at its structure. Highlight. You can see its structure is a number, and the number is 5.4. It's not a character like a word, it's a number, it's different. So numbers are different to characters. There are also other types of objects as well. So let's move now to integers. An integer is a whole number. Let me see. We'll make it an integer. Assign the value of 5 to the object A. Check the global environment for the existence of that object. Let's see. B. Okay, so now B is 5. We can print B. B comes down here. The structure of B, it's a number, and it's 5. We can also change it to an integer. An integer is a special type of number. So to change the number 5 to an integer, we use this function here, as integer function. So we're applying this as integer function to B. And we do that by running that, highlighting and running that code. So now, if we print B, we can see B. And we now know that it's an integer. An integer is a whole number. It's not a decimal. So let's start with 5.4 up here. Let's try it again. So remember, A is a number, 5.4. Let's call B a number 5.4. Let's print B. it's 5.4. The structure of B, it's a number. Now we're changing B to an integer, which is a whole number. Let's see what happens. We print it. It becomes 5 because it's a whole number, so it's not 5.4 anymore, it's 5. The structure is integer. Okay, so now let's move on to character element. In this instance, we're assigning horse, the word horse, to B. Let's print B. And if we print B, it comes up as horse. Let's check its structure. It's a character. CHR is a character. Now, as I've mentioned, we have numbers and characters. But we can also have other types of variables in R as well. Factors are a special type of object. Logical is true, false, true, false, true, true, false, like that. And a date. We have many other types as well. So task 3, assign your name to an object and then print the object. Should be pretty straightforward. The object could be anything, could be X, Y, any word you like. Next, vectors in R. A vector is a series of elements chained together in a series. In computer science, we say concatenated, C. So this is a numeric vector. Let's print it. If we print it, we see 1, 2, 3 values. The structure, it's a number with 3 values. It's a number, and it's a vector of 3 values, 5.2, 6.3, 7.4. We can see it up here in our global environment as well. Let's change it to an integer and see what happens. So same system. Let's see as integer. Let's see what happens. Okay, let's print it. So it's rounded it. So each element now in that vector is now a whole number. And it's an integer with a length from 1 to 3. And the integer is 5, then 6, then 7. Let's move to a character vector. So this character vector should be 3 characters long, and we'll call it D. So D is a character with 1 to 3 elements. Horse, dog, cat. Let's print it. Okay, we print it down here. And the structure, it's a character, 1 to 3, of length 3. Let's go logical vector. A logical vector is true, false, true, true, false. Yep, that's a logical. And this is important for managing data. So let's assign this logical vector to E. Let's print E. True, false, true. Let's look at the structure. Logical, length of 1 to 3. And you can see there what it is. Let's have a think about what these tests might create. 4 is greater than 3. Let's highlight that and run that. What do you think the output's going to be? Oh, it's true. Is it true? Yep. 3 is greater than 4. Is it true? No, it's false. What's going to happen here, do you think? 3, 4, the series, or the vector 3, 4, 5, 6 is greater than 5? Eh? Just think about that. It's checking each one. False, 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 true, maybe? Let's have a look. Right, false, 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 true. So only the 6 is greater. Okay. 229 is equivalent, or is equivalent to 229. Is it true? It's true. Okay. Let's try this one. Is that a vector? Is 5 a vector? It's true. Okay. All right. It's a vector, but it's one element. Okay. Is character feet? Is that a character? It's true. Cool. Is that a logical? T. No, it's true. Is that a factor? False. Okay, so that's not a factor. Factor is a little bit different. We can learn about that later, or next actually. So your next task is to create a numeric vector of the ages of people in your family, then report a logical to see if they are older than your teacher, 42. Okay, so create a numeric vector of the age of the people in your family, and then report a logical vector if they are older than your teacher, me, who I'm 42. So you can need to do that for task 4. Next one, factor vector. So factors are a special type of classification variable. Let's have a look here. So when we're working with data, we can have numbers, of course. We can have characters, like it could be, for a character, it could be what type of pet you own. Or it could be the name of your hometown. That would be a character. So that could be some educational data, and it could be relating to the name of students' hometowns. But other types of variables are called factors, and these have to do with generally the conditions, some special condition. Are you in a private school or public school? That's a factor. That's one example. Are you classified as short or medium or tall or massive? That could be a factor too. So this is a special type of variable. It's a type of classification. It's not a word. It's a special type of categorical classification of someone, and this has a certain. This is a certain type of data. It's understood to be a certain type of data in R. So let's run this code here. We have short, medium, tall, and massive, and these are different factors, you could say. So let's run these. Let's print it. Okay. Let's check out the structure. What is it? What does R think it is? It's a character. But we don't want it to be a character. For our data analysis, we want to make it a factor. And this will become more clear for you later on when we're dealing with factors. So let's try as factor. Let's see. Okay. So we're using the as factor function on F to create it as a factor. Now let's check F. Well, we can see it's up here. Let's see. Excuse me. Print F. Very good. So we're printing it. It says short, medium, tall, massive. Okay, that's good. Short, then medium, then tall, then massive. Okay. Check the structure. It's a factor with 4 levels. The first level is massive. Okay, why would the first level be massive? Isn't that a bit strange? Shouldn't the first level in that factor be the first one short? That could be a problem because we want it to be ordered in a certain way. So R put the factors in alphabetical order. So the first one is MA, that's the first one. So massive is placed as the first level, but we don't want that. We want short to be the first level. So in that case, we use the special function called the factor function, not the as factor function, the factor function. So we use the as factor function on the F object, and then we change the levels to be the vector short, medium, tall. So let's run this code and see what happens. So we run it. It comes out fine. We print it. Okay, we see the levels are short, medium, tall, massive. Excellent. Let's check the structure. It's a factor with 4 levels, short, medium, dot, dot, dot. Okay, we fixed it. So the first variable listed in the structure is the reference variable for the factor. This is the reference variable. So this will become important perhaps later on when you're doing other analysis. Consider another way to change the reference variable. You can have a look at this. Let's just do that again. So we can create a vector as factor G, the structure. Check the structure, it's a factor, and it's obviously got the alphabetical order again. Now we can use this relevel option, and we change the reference variable to be short. So let's do that. Relevel G, and the reference variable is short. Let's check it now. It's a factor with 4 levels, good. Short, but short is the reference, but then the next variable is massive. We don't want that. So that's why we should, if we want to do it effectively and change all the levels, we need to use that code there. This just changes the reference. Okay. Let's move on to manipulating vectors in R. We can also do basic math using elements, right? 1 plus 2, what's that going to be? 3. Okay, what's that going to be? 264. What's this? Enter. 18. This one, 8. This one, what's that going to be? To the power of 2. 4 times 4, 16. Square root of 16, 4. You can try this one here. Might be interesting to some mathematicians. What's close to 1? Interesting. We can apply more sophisticated math with vectors. So what's this going to be? The vector 4, 4 plus 1, 1. What's that going to be? 5, 5. You see, so this first element is added to there, second element is added to there. What about 10, 10 plus 2? Let's try that. What do you reckon that's going to be? 12, good. Okay, 10, 10 minus 3, 3. 7, 7. 10, 10 minus 6, 4, 4. 12, 12, 8. Multiplied by 3, 3, 3. What are we going to get? 36, 36, 24. Okay, 12 by 3. 12 by 3, 8 by 3. What about this one? 12, 12, 8 by 4. Similar, 40, 48, 48, 32. Just a short note, this here is the same as this. This here is from 10 to 15, integers, 10, 11, 12, 13, 14, 15. Okay, task 5, use 4 vectors in an equation. So 4 vectors. This is 1 vector. You need to create an equation with 4. This equation here uses 2 vectors. Next, manipulating matrices in R. So think about extending from an element to a vector, and then what's the next step? One element, like 1 plus 1. Vector is 1, 1 plus 1, 1. So what's next? It's actually like a spreadsheet of data. So let's have a look here. What we're going to do here is we're going to repeat 7 3 times. See what happens. 7, 7, 7. So we'll call this 7s. Okay, we're going to print 7s. We're going to repeat 8 3 times and call it 8s. Here we go. We're going to repeat 9 3 times, call it 9s. And then what we're going to do here, we've got those objects, 7s, 8s, 9s, and we're going to combine them together to make a big, what's called data frame. So we're going to combine the columns. So this is going to be column 1, column 2, column 3. Yeah? Column 1, column 2, column 3. So cbind data frame is the function that we apply to column 1, column 2, column 3, those 3 vectors, and we'll make a data frame. Let's see what happens. Okay. Oh, data. So we've got a data frame now. And it has 3 observations, 3 rows, and 3 variables, 3 columns. Let's have a look. Let's print it. Oh, there it is. So look at that, 7, 8, 9, 7, 8, 9, 7, 8, 9. This is row 1, row 2, row 3. Let's compare the function rbind, not cbind, rbind. Rbind means row bind, cbind means column bind. So let's rbind those three vectors to see what happens. Can anyone guess? So we're combining them by rows. So the 7s is the first row, the 8s is the next row, the 9s is the next row. So that's different. So data frame 1 is by columns, data frame 2 is by rows. Let's focus on data frame 1 here, or just data frame. We want to change this to a matrix. Remember, we have elements, vectors, and also matrices. So this is another type of data. So let's change it to a matrix. Let's see what happens as matrix. And we'll call it data frame matrix. Let's print it. Well, it's a bit different. Each column is named, but each row has a special number. Okay. 1, 2, 3, okay, and then comma. So this here, we call it a matrix. What would happen if we took this entire matrix and minus 2? What do you think? What's the result going to be? So 2 is taken away from each element in that matrix. I see. Now, that was the easy way, right? To just write df matrix minus 2. So your task is to do it the hard way. The hard way would be to create two matrices. The first matrix is like this. The second matrix is like this, but it includes 2, 2, 2, 2, 2, 2, 2, 2, 2. So you need to do it the hard way. Next, basic functions in R. So a function takes an input and produces an output. Input x, function f, output function of x. It's the same as what we've been doing. These are functions. So this is the input, this is the function, this is the output. We read backwards. Input, function, output. Okay. Let's consider 3, 4, 5 as a vector. Okay. So let's repeat 3, 4, 5, 2, 4, 6 times. What will that do? It's going to repeat 3 2 times. And then it's going to repeat 4 times. Then 5 6 times. Let's see what happens. It repeats 3 2 times, 4 times, 5 6 times, and that's a whole vector, because we're repeating 3 4 5 2 4 6 times respectively. Let's try this function here. The function is to create a sequence from 3 to 10 by 0.5. Okay. From 3 to 10 by 0.5. A function, so the input is 3 and 10 and 0.5. What's the output going to be? 3, 3.5, 4, 4.5, 5, 5.5, all the way to 10. So it's a sequence from 3 to 10 with increments of 0.5. What's this going to be? 3 to 10 by 0.5? Do we need to put these examples in, or do we just need to put the numbers in the right position? Let's check. We just need to put the numbers in the right position. That works. Okay, this one here. What would be the minimum of that? Let's do it a little bit differently actually. what is the minimum of that vector? The minimum of that vector is 1. Okay. We can do it this way again. This is a vector in here. So what's the max of that vector? The maximum is 3. So that's a function applied to the vector. Let's look at which min. Let's see what that function does. Which min? Okay, it's a function. Which one's the minimum? The first, second, third, fourth, fifth? It's the fifth. The fifth element is the minimum. Which max? Oh, 1, 2, 3, 4. The fourth? Right, the fourth is the max. What's the mean of those numbers there? The mean is the average. It's 5. What's the mean of these numbers here? 2, 4, 6, 8 and a missing value. NA means missing. Let's see the mean. Oh, NA doesn't work. Because there's an NA in there, a missing value. So let's try it again. What's the mean of this vector here? But we need to remove the NAs. Let's see. So the rule is remove NA is true. Now it's 5. We fixed it because we wrote this code here to remove the NAs from the calculation. What's the sum? 2 plus 4 plus 6 plus 8. Should work, and it does, 20. We didn't really need that, but we can use it anyway. We can ask a question, the function of this question mark here. If you put the question mark next to any function and press highlight, it comes up. It should come up. No results found. Sum. Here it is, sum. It tells you the sum of vector elements. So it works. So the usage is, the function is the sum. We put the vector elements here, and by default NARM equals false, meaning that by default this function does not remove the NA variables. So we have to change it to true so to get it to work. Right, we have to change it to true when there's an NA in there. Otherwise, we change this to false, it won't work. So I generally just keep things as NARM equals true, even though it's redundant. Okay. Task 7. Create a numeric vector with 10 elements and assign it to your name. Find its minimum value and the position of that minimum value. So it's create a numeric vector, 10 elements, and find its minimum value, and also which one is the minimum. And the vector is called your name. Next, basic functions in R part 2. Okay, just do some more functions. So let's check this function. Is NA. So we check each element in here to check whether it's an NA. Let's check. Is NA function. Takes the vector and checks. False, 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 true. False, 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 true. Okay, good. That's the NA there. So let's look at the next function. We're summing this here. This here is the same as this here. So let's run this code here in the middle. We get false, 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 true, true, true. Okay. So it seems as though there's 1, 2, 3 NAs. So there's 3 true values. So when we sum a logical, this is a logical vector here. When we sum a logical, we get back the number of true values. So what's the sum going to be? 1, 2, 3. Let's see, the sum of the logical, remember this is the logical here to there, and if we sum that, it's going to be 3. There's 3. A total 3 values in that vector are missing. Let's look at this one. R norm. Okay, 100. R norm. Let's have a look. Okay, R norm. It's n, which is the sample, the mean of 0, and a standard deviation of 1. Let's try that. Let's see what happens. Okay, there's a whole lot of numbers. It's a massive vector. So that's a really long vector. It's 100 elements long. Let's check it out. I'm going to stretch that out, open that up a bit, clear it. And I'm going to do that again. And I'm going to make the screen a bit smaller, like that. Highlight run. Okay. So we can see there's the first 18 elements there. There's the next 19 to 36 elements here. This is one long line, essentially. Okay, we'll take it back so we can see a bit better. Let's see what happens if we simply try it again. Click. Okay, so it changes the shape. But this is essentially one long line. And the final one is 100. And these are just random variables from about -3 to 3. This is common in statistics. You'll have the variable will be changed, so it has a minimum of about -3 and a maximum of about 3, something like that. This is quite common, changing all the variables to this type of standardized data. And this just happens randomly. If we do it again, changes. Okay, so let's do the next one. What's the standard deviation, which is a measure of spread, of this R norm 100? R norm 100 is the same here. R norm 100, mean is 0, standard deviation 1. Let's check. Standard deviation is very close to 1. See, it's pretty close. Every time you run it, every time you produce a random number, it's very close to 1. What happens if we boost the numbers up? Is it going to get even closer to 1? Yeah, it's quite close. What happens if we make it really big? Oh, it takes some time. Oh, it goes red, see? So it means it's working. Let's make it a bit bigger. Oh, it's working, it's working. It's working it out. Still working it out. Okay, very close to 1. So this is just a random number that it's drawing upon many thousands of random numbers from a known population, and it's sampling from a known population. We can talk about that a little bit more later. Okay, let's look at this function, cbind data frame. What's this going to produce? Okay, let's check it. Print it. Oh, okay. 1, 2, 3, 10, 11, 12. All right. Let's try this one. Col names of DF. What are the col names? Oh, they're strange names. The name is called vector 1, 2, 3, and this one here is called vector 10, 11, 12. These are strange names. So why don't we change the names? To change the names, we need to use the col names function on the DF data frame. Yeah, but then we need to read in different column names. So we're going to call it V1, V2. So this is a vector, V1, V2, character vector, and we're going to use this character vector and push it into the col names of here. So let's run the whole thing, and it's blue, so it ran well. So let's check the col names now. It's fixed it. Col names is V1, V2. Let's print the data frame. Okay, it's fixed it. It's V1, V2. So we've fixed the column names. We can change the column names of any data frame. Let's go to this function, plot. Okay, so we're going to plot x is like that. The x variable is 2, 3, 4, and the y variable is 6, 7, 9. Let's see what happens. The plot function. Any guess? There we go. There's a plot. The x variable here is 2, 3, and 4. The y variable is 6, 7, and 9. Let's try this function here, table, the table function. And the vector, that's a long vector there. How many ones? 1, 2 twos, 3 threes, 4 fours. Let's have a look. The table function. Okay, so we got how many ones? 1. How many twos? 2. How many threes? 3. How many fours? 4. How many fives? 3. Okay, so that gives us this is the table function. Let's try this one. We'll take a vector like this, so that's that vector before, and we'll assign it to the name test result. This might be the test results for children in your class. Now, how many children in the class? Well, I can't be bothered counting them, so I'll just ask how long that vector is. Let's see. The vector is 16, so let's assign, this means 16, right? So let's assign 16 to the kid count. Print the kid count at 16. So we can use the length function on a vector to see how long it is. Next one, let's call horse, cow, dog. Strange name, horse, cow, dog, but it's one character. Let's assign that single element to animals together. So what do you think this function is going to do? Substring. So we take this the substring function here, takes the animals vector, and the first one is the 6th, the last 6 to the 8th substring. 1, 2, 3, 4, 5, so 6th to the 8th. So what's this going to give us, do you think? We take the animals together element, we use the substring function to extract the 6th, 7th and 8th. The first is the 6th, the last is the 8th. Let's run it and we get cow. Okay, so this can be helpful when we're trying to deal with data that's concatenated. We can use a substring function. Let's move to this here. This is a character vector, dog, cat, horse, 3 elements. Here we go. We assign it. Let's see what this function does. We're going to use a general expression function. This is called grep. We're going to grep and we're going to look for cat in this vector. What's the result going to be, do you think? Where's the cat? Is it the first, second, or third? It's the second element. Okay, that's good to know. What about horse? But this isn't grep, this is grep L. L means logical, maybe. Horse. Is it true that the horse is in the first element? No. Is it true that the horse is in the second? No. Is it true that the horse is in the third? No. Okay. Yes, it is. The horse is in the third element, so you return a logical here. Okay, task 8. Create a numeric data frame with 3 columns and 6 rows. Name the columns your 3 best friends. Okay, so numeric data frame, 3 columns, 6 rows. Name the columns your 3 best friends. Okay, next, basic functions in R, part 3. So let's use that, let's check that test result. That's the test result for the kids in your class. Some kids got 1, other kids got 7. We can use a table. This gives the frequency. This is the elements. These are the frequency of the elements. 1 person got 7. So we know that, let's read it and create X. There's X. So let's see. Let's make a bar plot. So we're making a bar plot now with x as the object. The y label we're going to call frequency, and the x label we're going to call scores. So let's run that whole thing, bar plot. Oh, beautiful. So now you've just created a plot. The frequency of kids that got 1 point is 1. 4 people got 4, and only 1 genius got 7. Let's have a look here. Unique function. Strange. Unique function. So what are the unique scores in the test, do you think? Let's check. Or in this test here, it's a little bit different in this test. The unique scores. Let's check them. The unique scores are 1, 2, 3, 4, 5, 6. Okay, there's no other different ones. 1, 2, 3, 4, 5, 6. They're the unique scores. So the unique function reduces the vector, the entire vector, to its unique elements. Okay. Now let's think, how many unique elements do we have? So we can combine the functions. We have a unique vector. We have a vector. We can check its unique elements, like that, right? And we can check how many unique elements are there by using the length function. So we're building, there's 6 unique elements in there. So we're building functions on functions like Lego. Okay, duplicated, what's this going to be? The duplicated function. Let's try it. What's it going to return? Let's see, false, true, false. Eh? False. 1. That next element, that is a duplicate. Let's see the next one. 2, is that a duplicate yet? No. Next one, 2, is it duplicate? Yes. Okay. So you see that this is a duplicate. This is a duplicate. This is duplicate, duplicate. Okay. So this helps us identify duplicated variables. And this is important maybe if we're checking large data sets. We can check that the names of kids are not repeated. So this is an important step we can do to check the data. Now this one here is a really important function. This function here, percent in percent. So for this one, we take a vector, 1, 2, 3, 4, and we check each element in the vector to see if it's matches with the other vector. So let's see. 1. Does 1 exist in the next one? Yeah, it does. So that's true. Let's see. 2. Does 2 exist anywhere here? Yep. Okay, good. So it's true, true. Does 3? Does 3 exist anywhere in this next one here? No. 4. Does 4 exist in any of these ones here? No. So if we run this, we're going to get true, true, false, false. Let's check. Okay, true, true, false, false. It's true that this element exists in the next vector. It's true that this element here exists in the next vector. But it's false that those ones do exist in here. So this is an important way to reduce data. Let's try this one here. What's the result going to be? Let's see. True, false, false, true. True, false, false, true. Right. So task 9, create a character vector with the names of 4 friends. Create another character vector with the names of the friends that you have spoken to in the last 2 days. Sum the resultant logical vector and describe what the number means. Okay, we're going to sum the logical at the end. And I'm sure that you can describe what that number means. Okay. Next, basic functions in R. Okay, so we're going to create a data frame with 2 columns. First column will be 1, 2, 3. Second column 10, 11, and missing. So let's create the data frame. Okay. Now let's use the complete cases function on the data frame. Complete cases. So let's check the data frame first. Tell me, is the first row, the first case, is that complete? Yeah, there's no missing data there. Is the second row complete? Is it true? Yep. Is the third row complete? No, so it's going to be true, true, false, I suggest. Let's have a look. So complete cases df2. It's a logical, true, true, false. Okay. True, true, and false. Okay. So let's assign that to a logical. So this is the logical here. True, true, false. Let's print it. There it is, true, true, false. Let's think about the number of rows in df2. Let's check. Number of rows in row 3, it's correct. Number of columns, 2 columns. What's the structure? It's a data frame. 3 observations or 3 cases and 2 variables. Very good. You can see them there. Col names. What are the column names? Okay, they're quite long. Okay, they're a bit strange. We can change those later. Dim. Dim means dimensions. This is just like doing number of rows and number of columns. Remember, we have 3 rows, 2 columns. So if we dim, that means just 3 rows, 2 columns. Let's change the name of the data frames to V3 and V4, the columns. Let's check. Okay, we've fixed it, V3, V4, that's fine. So maybe we want to find out which column is named V2 now. Which one? Let's check. Actually, it might need to change that to V3. Which column? Oh, which column in V? Which column in? It's tricky. DF. Let's print DF. There's DF. DF is a different data frame. So which column is V2 in DF? It's the second one. So which of the col names, which of these ones is equivalent to V2? It's the second one. 1, 2, this one here. So all these steps are useful when working with data. Okay, what about this function, a paste function? We're pasting x with y. And the sep is 1. Sep is the minus. What is that going to do? Oh, it creates a new variable, a new character element called xy. Okay, that's useful. Maybe we can make some labels like that. How about if we paste together 6, 7, 8, the vector, with another vector, 1, 2, 3, with a separator of nothing? Okay, let's try. 6, 1, 7, 2, 8, 3. Okay, so let's run it. Check it. 61, 72, 83. Okay. We can change it to as numeric. Okay, because this was a number originally. See how that was a character with the exclamation points around each one? That means it's a character. Now we can change it to a number. Right? So it's a number now. That's good. Let's do a little bit of statistics. Now, let's think about installing a package. So in your packages, you might have a few here, because you haven't installed many. I've installed lots. But you, because you're just beginning maybe, you won't have many. So you want to use this package here. So some really smart statisticians created this package to help you. Now let's see who created it. Some people. This person here, Marco. Thank you. Do we know where Marco's from? Maybe not. But he created this package here called EFF size. And it's to help you understand the difference between different vectors. Like how different two vectors are. Effect size. You should have learned this in your methods class. So in order to use those special functions and that special package, you have to use the library function. Sorry, you have to use the install package function on Psych. So you run that, and it downloads it from the internet. And it should go through and download it all from the internet and then put it into your package library. And you should check, yep, it should be there now. And then when you want to use it, you press the library function and you write the name here. So now it's functioning here. It should come up with a tick. Mine was already there. So effect size is comparing scores across groups. So you might have a control group, and this control group might be the results of an exam, just a small quiz with 10, what's more than 10 I think, but it's a vector of many scores, and this is the student control group, and this might be some classroom where you're just teaching normally. And this is the control group scores. So let's check. Yep, that's the control group scores. This here is the special classroom where you did some special differentiated instruction. So this is called the treatment group. So we've got control group and treatment group. So we want to work out what's the difference, who's scoring better and by how much. So we look at the treatment group compared to the control group, and we use the Cohen-D function. This is an important function, important statistic for differences between groups or outcomes. So we can use the EF size package here, and then we write colon, and then the Cohen's-D function. So we go package, function, first group, and reference group. Let's see what happens. Okay, we get an answer. We get a Cohen's-D estimate of 1.3. Well, that's large. Okay, so there's a big effect. And we get some confidence intervals as well. Okay, this is all interesting stuff. So your task 10 is to create two numeric vectors of scores from two groups of students and report the size of the difference. You can make it up if you like. You can just imagine that you have two groups of students, create one score for a control group, another score for a treatment group, and put them into the function there to see the magnitude, the size of the difference between the scores of the two groups. Okay. Let's see. Let's move on to number 11. Do students of higher ability have a higher probability of getting questions right? That's a bit of an interesting question. Do students of a higher ability, this means maybe higher total scores, have a higher probability of getting questions right? Do the smarter students have a higher probability of getting the students right? So this tries to make us think a little bit more probabilistically. Statistics has a lot to do with probability. So imagine you're the top student in your class, and it's a basic question. Do you think you're probably going to get it right? Yeah, I think there's a high probability. So probability can be between 0 and 1. 1 means certainly, like you're going to get it right. 0, you're going to get it wrong. So if we're thinking about children, students, or university students, or anyone performing in a test, we need to start thinking probabilistically. And we can think about assigning a probability level to that person for that question. We may be able to assign a probability level to each person in Kazakhstan for each question in the UNT. That could be interesting. So let's have a think about how we might do this. You don't need to get completely over the math, but we can start to do some tricks in R concerning probability. So we're going to create a vector here with a set of numbers. We'll call this variable x. We're going to create another vector here with a set of numbers. We'll call it variable y. Now here I'm going to use an outer function. So the outer function takes this first vector and the second vector, and it applies a function. Now this one here means multiply. That means multiply. So we'll see what happens. I see, we've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 times 5 is 25, okay. 4 times 4 is 16, so it multiplies each element by each element in the other vector, and they go out. Outer, this x and this y here go out, and each element multiplies itself. Okay, so we can create data. That's interesting. We can create test type data maybe. Let's have a think. So we're going to print it, assign it to that object, print it. Okay, cool. Let's have a look at this one here. This is a special function. You can check that math if you're interested. But, there's the math there, but let's see what happens. -3 up to 3. Okay. Okay, that's interesting. Imagine if you had an ability level of -3. That means you're not doing so well on the test. You might have the probability of getting a question right of 0.04. That's pretty low. Imagine if you scored a little bit higher overall on the test, and you got a standard score of -2, which is a lower score, but not as low as your mate who didn't do very well at all. You got a -2. What would be your probability of getting the question right? It's 0.11, 0.12. Okay. Let's try the next one. You did a little bit better than your other two mates, close to the middle. -1. What would be your probability of getting that question correct? 0.2, 0.27. Okay. What if you're the top student? You score really, really high overall. What would be the probability of you getting that question correct? 0.95. Okay. So it looks like we're assigning a special function to take these special scores, these special ability scores, and change them into probability scores to get a question correct. Alright, so let's try to apply that same algorithm to this object here. Okay, that's a large number of probability values. So imagine there's 101 people that took the test, and we're just focusing on one question, and the slowest person in the class, they're assigned a really low probability of getting the question right, and the highest person in the class, the person who scores really well overall, top scorer, he's assigned a really high probability, 0.99 probability. Okay, all right. So let's see if we can plot this here. We'll plot it. So we use the plot function. We use this vector. We turn off the x-axis using this code here, and comma. Then we write the main, the title, press comma. The x label, student ability, and the y label is probability of getting item correct. bracket. We can also change the axis, but let's just first plot here. Oh, that's nice. There we've got a graph. So imagine this is a certain question in UNT, and you have student ability across the bottom, high ability here, low ability here. And we have this is 101 kids that did UNT. Okay, so this is this nice curve, nice function here. So we're assigning the lowest kid who scored really badly, we're only going to give him a really small probability of getting the question correct. This top kid, we're going to assign him a really high probability of getting the question correct. And this is just a nice mathematical function across all people. So we want to change the label at the bottom across here to be between -3 and 3. So to do that, we use the axis function for the x-axis, which means 1, and we're starting from 0 to 100, and we're applying labels from 0 to from -5 to 5 with increments of 1. So let's just run that function there, and there we go. That should be it should be fine. So now you can see that if you did really poorly in the test overall, then you're going to have a really low probability of getting this question correct. And this is just theoretical. If you did really well in the test, you'd have a high probability. If you scored in the middle of the test, like got a B or a C, then you might have something like a 50-50, 0.5 chance of getting something correct. And we need to start thinking about the meaning of that 50-50. If you have a 50-50 chance or a 0.5 chance of getting the item correct, what does that mean? It might mean that it's quite a good challenge for you. It might be too difficult if you get a probability value down here. The question is too difficult. The question is too easy if you're a top scorer. This question is too easy. But if you're a middle scorer, overall you have an average score, and this question's quite well targeted for you. So we need to think about that. So just a short note here. Modern large-scale assessment systems transform total scores to special student ability scores. Okay, so instead of using total scores, they use a special ability score between about -5 and 5. It's actually between -infinity and +infinity, but generally it's between -5 and 5. And those scores are just a transformation of the total score. So if there's a UNT and some people got 1%, other people got 99%, then that would just be transformed to about -5 to 5. And if you got somewhere in the middle, you'd be like 50 or 0. 0 would be your score. Modern assessment systems transform those percentage correct scores to log odds scores. So these are called log odds. It's a mathematical function that run between -infinity to infinity, but generally between -5 and 5. So each total score is assigned a probability value for each question. So if you got a total score of that relates to a score of 0, and your other mate got a total score that relates to a score of 0, you'd get the same score here. Okay. Alright, so task 11. If your total score was transformed to become -5, what would be your expected p-value, your probability value for question 5? So if your total score is transformed to become negative 1.5, so you're here, what would be your probability value to get the question 5 correct? What if your transformed total score was 2? Okay, so 2 is about here. You just tell me what would be the probability of you getting that question 5 correct. Okay, next, basic functions in R. Okay. So we'll do some more functions. So these can be objects as well. Functions can be objects as well. So in our global environment we have data and we have values, but we can also put functions into the environment as well. So let's think about some basic math to do with a circle. Pi, what's pi? Pi is 3.141. Okay, we should know that. Pi times 1 squared, that's the area of a circle with a radius of 1. What would be the area? Okay, 3.14, okay. So to make a function, we need to follow rules. We have a function name. We write the function, or we write function, then we write arguments, expressions, and then the output. So maybe we've got all these circles, we've got a maths test and we've got all these circles we need to work out the area of. So we could do it one by one with the calculator, but it might take a lot of time, you see. So ideally what we want to do is create a function. We've got a whole lot of circles in our maths test that we need to work out the area for. So we write the name of the function, we write the word function, we take the argument, the input is r, and which is the radius we're going to use, and then we write the expression. The area of a circle is pi times radius to the squared, and then we return area that's going to pop out. So let's check this out. We create the function. So there's the function, circle area. So let's run the function with a circle radius of 3. Let's check. Okay, so there's our area of the circle with a radius of 3. There's the area of our circle with a radius of 4. What's this going to do? We're putting a vector in there. Because our test, we've now got to do radius 1, 2, 3, 4, 5. Let's see. Okay, so we get 1, 2, 3, area, the area with radius of 1, the area with radius of 2, area with radius of 3. Okay, 4 and 5 as well. So your task is to create a function to calculate the circumference of a circle. And there's a tip for the function. 2 times pi times r. And you should be able to write your own function and maybe put a vector into that function. Next one, write a file to your working directory. Okay, so now we're going back to the working directory. Remember our working directory, what is it? We can check it down here. Desktop EDSC R, okay, that's cool. We can also have get working directory like that. Check it. Okay, there it is there. Nice. But in this instance, we want to place something that we've created inside this environment here and put it into the working directory. So let's think about what we've got here. We've got a df2. This is a special data frame, right? but maybe we want to send this to our working directory and create an Excel file for it. Okay, so let's see. We can use the write CSV function on the df2 object, give the output a name. We're going to call it mydf CSV, and then row names. So right now you can go to your working directory, open your working directory, my working directory here is here, and you can keep it open if you like. I'll keep it open. And what I'm going to do is, where are we up to? Okay. I'm going to create it in here. Now it already exists because I've already run it and checked it, but I'm going to change it to new. Let's see what happens. There we go. It just created it, right? So just run the normal code, and you'll notice that it says row names equals false. So that means that I delete the extra row names. Let's try here. If I run that, run, then I'll get this one here. And for this one, if I click it and check, I've got the column called row names. This is an extra one that's included. But if I want to remove that, then I can if I like. Right? Okay. If I want to remove that row, I can if I like. I just write row names equals false. So now we can get the CSV file from the working directory and put it in RStudio. So let's take it from the working directory and put it back into RStudio. So this just gives us some practice to pull it to get objects from the working directory and put them in the RStudio environment up here, and gives us practice to get the objects back into the working directory from RStudio. So if we want to get it from the working directory, then back into the RStudio here, we need to use the read CSV function. So let's check. Read CSV function with this name, that's what we want to get back, and we'll call this the df2r. Let's have a look. Okay, there it is, df2r. So there it is, we've taken it back. Okay, we can print it. Yep, that's fine. Okay. So your homework is to create a data frame, or your work now is to create a data frame with the names of 5 friends and their respective ages, and then write it to your working directory. So create a data frame inside R here, and then with your friends and their ages, and then write it to your working directory. Okay. Next one, removing cases, rows with different values. Okay, so we're going back to the complete cases function. So let's just print this for now. Here. df2r. Okay, there it is. Okay, so let's print it one more time. df2r. Oh, okay. This is a data frame. Now we're going to run the complete cases function on df2r. So we're going to get true. First one is true. Second one is true. Next one is false. It's not a complete case. We want to get rid of it, say. So we run the function on df2r and get the logical. The logical is true, true, false. First person keep, second person keep, last person get rid of it. So we can think about this, this logical and how we might apply it to the data frame. So just think about carefully how, we're nearly finished guys, think carefully how we can manipulate data frames. So this is a data frame. Look at it carefully. Row 1, row 2, row 3. This is the first variable, 1, 2, 3. Second variable, 1, 2, 3. Third variable, 10, 11, and NA. Let's have a look. These square brackets help us subset. Let's see, the square bracket here helps us subset this data frame, but we don't choose anything in this space, so we don't, it's just the same thing. That is the same as that. What happens if we just put a number 1 before the comma? This is for rows, this is for columns, so we want row 1. Let's see. We just get row 1, right? Okay. Next one. Row 1, column 1. What are we going to get? Probably going to get that one, eh? Let's have a look. Right, we just got that first one. Next one, row 1 and then 1 to 3. Okay. Row 1 and columns 1 to 3. So row 1, columns 1 to 3. Are we going to go 1, 1, 10? Let's check. Right, 1, 1, 10. Row 2, columns 2 to 3. Row 2, columns 2 to 3. 2, 11. 2, 11, right. Minus 1, 1 to 2. Okay, so minus means remove. Alright, so we're going to remove 1 and just remove row 1 and then have columns 1 to 2. So we're removing row 1, that's out, and we're just having columns 1 to 2. So we might have 2, 2, 3, 3. I think, let's check. 2, 2, 3, 3, good. Okay, now we're removing 3, removing row 3 and including all the columns. So we're removing row 3 and including all the columns. So we should have 1, 1, 10, 2, 2, 11. Let's check. 1, 1, 10, 2, 2, 11. Correct. Okay, what about this one? Same data frame. We are putting this vector here, a vector of rows. What the heck's going on here? It's a vector, but we've changed the order. We've changed the order of the rows. So now, if we change the order of the rows, this should look like sort of reversed. 3 will be first, 2, and then 1 will be last. So 3 will be the top, 2 will be the middle, and 1 will be the bottom. So it's going to go 3, 3, NA, 2, 2, 11, 1, 1, 10. Let's check. Yep, 3, 3, NA, 2, 2, 11, 1, 1, 10. Okay, so we can change order. We can change it to be whatever order we want. Reverse the columns. Yep, we can reverse the columns. So V4 is going to be first, V4, V3, then X. Let's see. Yep, V4, V3, then X. Okay. This one looks strange. Is the square brackets subsetted in that first instance, so that means that we've got only the first row, and then we're subsetting again, 2, 3. Okay, what's that going to be? Columns 2 and 3. So that would mean just here, right? Okay, let's check. Is it going to be 110? Okay, it's 110, correct. So we can subset and subset. To see a variable from a data frame, use the $ symbol. Okay, so this is the data frame. There we write $, then V3. 1, 2, 3. So V3, 1, 2, 3. We can see that as a vector. 1, 2, 3. if we just want to get that vector out of that data frame. We use the $, data frame, then $, then V3. Next, 10, 11, 12, yep, that's V4, V4, 10, 11, 12. Okay. Next one, df2r, V4. Okay. We can just remember we've got the data frame, then we've got the data frame vector 10, 11, 12, 10, 11, 12, V4. And we can read that into here, into this vector. And the structure, it is an integer, 10, 11, 12, with an NA in it. So, let's say you want to only include the row students that have complete cases in some of your data. For this, we can place a logical vector in the position where the rows are to subset only the students with complete cases. So let's go back. Remember here we have df2r, which is here, right? But we want to remove this person because he's got a missing case and it's just going to ruin our data analysis. So we run that and we get a logical. The logical means true, true, false. So if we need to use this logical to create a new data set that excludes that final row. Okay. So what we do is we can put that logical inside that row area of the square brackets. Let's see what happens. Okay, so we remove the final row because that logical removes the rows. It only makes row 1 and 2 true and then final row false. So we can use this exact same expression here, here, and create the new data frame here. Print it. Okay, so now we've got a clean data with no missing values. So your task here is to create a data frame of students' age, gender, and test scores. So the first column is age, next is gender, next is test scores, and includes some missing values. Then rearrange the columns and sum in the data frame, and subset only the students with complete cases in a new data frame. So that's your job. If you're interested in some more of the mathematics involved with the outer function and the probability values, then you can do that math there, but that's only an option. And that brings us to the end of our first day. So much fun to be had. And I'll be finishing the session now, and this is a flipped classroom environment, so you'll be working by yourselves. If you want help, then please contact me anytime on Zoom. I'm available all day. Okay, thank you guys.